In this video, I'm going to talk about physics of focusing light. That's known as Huygens principle or Huygens principle. According to the principle, every point on the wavefront generates a spherical wave. For example, we have a plane wave on the left side of the screen that's propagating from left to right, and these vertical lines are wavefronts. If we zoom in on one of the wavefronts, we have infinitely many points, and each of them are generating a spherical wave. And what we see in the propagating wave is the result of their interference. The interference effect at a given point in space can be obtained by superposing all these incoming spherical waves. Since there are infinitely many points on this plane, I'm going to show you how the interference works using just a few points. Here on the incoming side, we have point A that's generating a spherical wave, and it's going to reach the point B at a certain phase. The phase difference between point A and point B is given by this equation. So this portion is the distance between the 2 points, and here we can see that the phase difference is proportional to distance. And we can do the same thing to the next point. We have another point here generating a spherical wave, and its phase difference is given by the same equation. We do the same thing to the next point and again and again. So the net effect at point B is given by adding up all these spherical waves coming from the incoming side. From this picture, we can get a hint that in order to focus energy at a given point, all these waves must meet at the same phase at that point. In other words, we need constructive interference at the focal spot. And like we saw before, phase or phase difference is proportional to distance. And if we look at the picture here on the left side, each point on the incoming plane has a different distance from the focal spot. And this portion of distance shown in dashed lines is what I'm going to call extra distance. Extra distance produces extra phase, and extra phase is different from point to point here. So because of different extra phases, the spherical waves are never going to meet at the same phase at the focal spot. Extra phase is given by this equation. This portion of equation is the distance between the 2 points, and here we're subtracting the common portion of distance from it. The common portion of distance is simply the focal distance. So we need to do something to get rid of the effect of extra phase and focus energy at the focal spot. We can do that by introducing another phase at each point here. That phase is called target phase, and the target phase is equal to extra phase in magnitude and has the opposite sign. So now with the target phase, all these spherical waves are going to meet at the same phase at focal spot, and there we're going to have a constructive interference. And the magic that happens is that destructive interference occurs on the rest of the area in the focal plane, and we're going to have a intensity profile that looks like this given by a sinc function. For us, the incoming plane here is going to be our metalens, and each point here is a unit cell. So that was it about the physics of focusing light and metalenses.